Thanks. Hi. How you doing? Good morning. Thank you, whoever that was. That person got some sleep. How was day one? I'm going to start calling out our non-participants. You did not clap. You did not clap. We got to work on that. Going to just put that snake down there. Is that better? Again, I'm going to start today with just a sincere thank you for being here. Yesterday, for me, was a huge amount of energy. I sat down maybe once. I thought it was absolutely bonkers amazing to have so many conversations with so many people. I'm just grateful and I'm humbled to be around so many awesome humans. And I mean that because I get stories about you that may seem non-trivial, but they just make me proud to be part of the community that's here. You all set this, I set this stage, but you all set what this is. So when somebody goes to dinner and does some random act of kindness and expects nothing in return, and then ends up having a conversation with the owner from the Kalahari, and he's bragging about how awesome all of you are in this, it just makes me proud. It makes me proud that the staff that works here and works tirelessly to be part of this is excited to be with all of you. Because there are other conventions that come through, and they destroy the place. They're taking sponsor stuff and throwing it in the parking lot and games and this and that. And while some of that stuff at times is fun, I like to play, well, not that stuff, but I like to play pranks. I like to have a good laugh. I just want to say thank you for just being awesome people because it radiates in all the things that we do, and it sets the stage for the kids that are around, right? We set the example for them in what cool stuff really is. So thank you for that. I appreciate it. Now, yeah, absolutely. Now, I really thought, when we bought a puzzle in Texas for everybody, it was such a cool metaphor of us as a tribe working together to try to get 1,000 people in. I'm not really a puzzle person. That's too, ADHD for me. And I really thought you would be really mad when I bought a pixelated puzzle of nothing. I didn't know that was possible. And yet you all finished it. But you didn't finish it because you did it. And this is just another indicator of why I love this industry. You found a different way to do it. This is software, right? We hit a block, we get a can-do thing, and we're like, we're going to go this way. There's got to be a better way to solve this problem. This shit's too hard, and in this case, it's too hard. So what did y'all do? You flipped it over. You took the obvious thing. You turned it over, and you realized that there were letters on the backside of it that grouped the puzzle pieces in quadrants. And you're like, I just made the problem smaller. We can do this. And within a day, you solved the damn thing. So the next time I'm going to have to take the puzzle, flip it upside down, because I didn't look at it, spray paint all the pieces so that it lasts for 3 days. But I think that it's cool. I think it's a cool thing that we can come together with people that we don't know and we can accomplish a greater good, in this case, have a little fun. But more importantly, we can find a different way to solve a problem. Which brings me to that.us. And I want to spend a little time talking about something that I'm super passionate about, and it's the thing that we've done for the last couple of years. And I'm using this time because I can explain it better with my words than I can write it and use CSS and try to do some fancy stuff online. A number of people yesterday raised their hand and said that their life has been impacted in an open space, right? How many people this is a thing for them? They look forward to being here. 3 people, thank you. You have completely destroyed my business model. You're welcome. 10 years, I got you, brother. That kid's going places. You know, like the puzzle, when COVID hit, it was time to flip it over. Things that had been rolling around in my head for years, many years, of how to connect everybody differently, it was time to see if we can make that happen. There's a lot of special sauce that's in there. Was anybody, I know there wasn't a whole lot of open spaces yesterday, but how many went to one yesterday? How many people keep your hands up, how many people threw one on? Threw an open spaces on a board? Yep. How many people plan on attending? Now, the rest of you who don't have your hands up, raise your hands. See, I just tricked you into feeling guilty because you didn't have your hands up. You need to try it out. There's something special that happens with a small group of people in a place where everybody's, I don't want to say equal, but kind of on an equal playing field, right? There's no podium, there's no microphone, there's a whiteboard. We can have a conversation. We have acoustic space where we know how to play off one another and have a dialogue. And we can learn a lot more because it's contextually aware. Hey, you had this problem. Cool, I had something similar. Well, let me talk about it this way. Oh, hey, I got this question. Oh, I didn't even think that was a thing. What if we went over that way? Well, I don't know, why don't you show me some code? There are TVs set throughout that are off. They all have HDMI cables. Why is that? Because we all have computers, and some of us have many of them. Feel free to use the big display and put the code up and do the thing. That's what they're there for. My eyes are old. TV's got big print. But use them. In that circle, there's this opportunity to have things happen. And it doesn't have to be just about code. For the last couple of years, I've had conversations with people about mental illness, how they're getting through the day, their families, kids, how to be a dad, entrepreneurship, money. Why does that not us up? Ugh. Why does the scheduling piece on that.us not work? I don't know. Let's get online and figure it out. What, right now? Yep. Why not? And so we had this opportunity to say, how could we interact as software developers? How could we interact as technical people differently? And more importantly, how could I connect you with people who aren't here? There's 1,000 of you here. That's cool. But it turns out there's like 7 billion people in this world. Somebody's got the answer. Somebody has to have something that's super close to the thing that you're doing. I don't want to replicate, and if you take anything from what I'm about to say, I don't want to replicate the experience that's here up there. I guess that's the cloud. I want to take the spirit of that and change it. The stuff that we do on that.us isn't meant to be pixel parody for our time together here. It's meant to try to scale that circle, those 20 people who are trying to have a conversation and need to have it at any point in time. It's my goal that our platform can figure out how to connect you with the people who need to be in that conversation. I know right now it's a little bit manual, and I'm in the background kind of like, can you be at this? You all know how V1 works. Yeah, we'll put it in a form, database, set, boop. But we have an opportunity to use the internet. We have an opportunity to use a whole bunch of technology, mumbo jumbo, to connect people at a time of need. At any time, anywhere. Fire open a video call and just talk. And that's my goal with that.us. And you're going to see me continue to invest in it. You're going to see me to continue to talk about it so that I can refine this message. And you're going to continue to see this shit grow. Because this is the family reunion, and the things that we can do here are different than the things that we can do online. And I believe that we should be playing together every day of the year. So that's my commitment to you. I just want your feedback. I want you to try it. I want you to experience the magic sauce that I've had in there that's changed my life, because there's something special about it. Now, many of you bought some merch. Many of you bought coffee for the kids. We're going to put my coffee out there. I've been trying to do this for many years. It's out there. I appreciate everybody who bought something. It goes to supporting this. It goes to supporting the night crawlers. I think they're over there. Yep, raise your hand. Let's give them a big old round of applause. How many people have been by the marble wall in that STEM room in the back corner? Oh, seriously, more of you need. It may say family track, but your inner geek can come out. Like, go back there and check out what these kids are doing. See who's got more skills. Because there was a, don't yell at me, Scott, if I get the story wrong, but there was a couple kids that decided to connect the marble walls. So instead of just going around one cube, let's try to go around 2 cubes and build a bridge across. And I just love that. I love that because it's like the puzzle. Somebody flipped the problem upside down and said, let's do it different. Super cool. So, it's weird to stand up here and have the stage. It's weird to feel like I have some kind of special privilege. I don't. I'm just a dude that has a clicker and can stand up 3 feet taller. But one of the great things about what I get to do is I get to kind of meander, if you will, through the industry and meet people. And I tell so many of you time and time again that this industry is small. There may be 7 billion people in the world, but I'm telling you, it is small. When you step out and you ask and you get involved, you realize that you're more connected to folks around you than you may think. And it's super cool. So I've got to meet some amazing people, some of which I have been heroes of. Wesley got up here last year, huge fan of the man. It was super cool to meet him. And he's here this year. I don't even know if he's in here, and I'm bragging about him. Just super cool. So Alan leaves this quote on his profile. Alan's going to be our keynoter. He leaves this quote on his profile. Making something 10% easier makes it accessible for 10 times as many people. True story. I wanted nothing to do with software development when I started in my career. Not a damn thing. I didn't want to sit behind a computer. I didn't want to write the code. When I was in school, I did the whole COBOL thing, go to 100, blah, 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 print on green bar. I'm like, who does this? This is horrible. Why would we ever just sit here and make these 900-page reports? I realize that some accountant wants that stuff, and it's got like our payroll number on it, but I love the web. And for me, what got me into software development was, hey, computers can scale. If I wanted to tell a story and I wanted to teach people, I could write this crazy-looking language thing, and the next thing you know, it's in some browser, and anybody can get it anywhere, and I only have to do it once. I was like, that's freaking amazing. I don't get off on the whole like internals of code and all that. I get off on the fact that I can use computers to do the job for me. They can make me be faster. This conference is not possible at the cost that we do it, at the way we do it, if it wasn't for the fact that we wrote all of the software to run it. Most people, they go buy a C-Vent or something, or C-Event, whatever that crap is, and they get all these things and connect all this crap together. No, we wrote our own ticketing system. It's cool. We wrote a profile. We use Auth0. We use ngrok. We use this. We use that. We did it. There's 4 of us, and I'm proud of it. I'm proud of it because of the same way you guys write software and test it and ship it, and manage it, and make a thing and use computers to do a thing. We made a thing to make your experience better, put it online, did a thing, whoopee-doo, there it is. And we get to do it and interact with you guys. So I think about this kind of thing all the time because it really hits home. Now, I'm going to release the stage to Alan here in a minute. I'm super humbled to have him here, super honored. He's been around Microsoft and Twilio, started companies. But there's this little tool that I tell people to use all the time, and it's called ngrok. How many people use ngrok? Oh, holy hell. Everybody, go to your computer, go download it, super easy install, go use it. Like, life-changing stuff. Love this tool. It's like one of the first few things I install in the thing. But when I saw the title of today's talk, I thought about one of the things that we often overskip, and that is how do we deal with errors and just everything in life in that. Somebody was asking me over the weekend, hey, I want to submit a talk, but I don't know what to do. I said, well, what are you doing? It's like, well, I work in a customer-facing role. I don't know how it's relevant. I go, what? Like, do you have a website? Oh, yeah, like the customer-facing role of the website. I'm like, oh, yeah, that's not relevant at all. I'm like, how many times does that thing blow up? All the time. Wouldn't it be nice if you could fix it fast? Yeah. Do you have that in place? No. Why don't you talk about your journey and getting better error resolution and how to have a better customer experience because you know how to actually debug it? We all have something to contribute. Just because it doesn't feel like a certain thing doesn't mean that we don't have value to give to one another. So with that, let's give a huge round of applause for Alan Shreve. He's going to take the stage. Go this way.
All right. Hello. Good morning, everyone. It's so nice to be here. Thank you all for having me. It's really a pleasure to be here. Do we get that up there yet? All right. Cool. Thank you all for having me. I'm really excited to be here. Really excited to share some of my learnings about errors with you. I want to talk about errors really because they're one of the things that it doesn't matter what language you're using, what frameworks you work in. It doesn't really matter the vertical of software that you build for. It is universal. These things happen everywhere, and that's one of the reasons that I wanted to talk about them. And we'll go into some of the other reasons that they're exciting as well. Thank you so much, Clark, for that lovely introduction. Really happy to be here. This is my first THAT conference, so I'm really excited. My name is Alan Shreve. I am at Incontrovertible on the internets, if you want to find or follow me or see any of my work. I'm the founder of ngrok, as Clark mentioned, although that's not what we're going to be talking about today. Ngrok is the fastest way to put anything on the internet. It is Nginx as a global service or a way to create programmable global ingress. But we'll start talking about errors. So the title of the talk today is "To Err is Human. To really screw things up, you need a software developer." This is lightly paraphrased, but that's what we're going to be talking about, is really about errors. We're going to go over, we're going to be talking about what they are. We're first going to kind of like define what errors are and what exceptions are. After that, we're going to talk about how we interact with errors when we're working on software together. So the different mechanisms that you see for handling errors, for creating errors in programming languages or different frameworks and systems. We'll talk a little bit about how we handle errors, like what do we do when we encounter one. And then we'll get into kind of the meat of the talk where we talk about some things to take away, right? Of like, how can we design better errors for our end users? How can we design better error systems for developers who are consuming our software? And then I'll share some of the learnings from building error systems at ngrok, some of the real world things and engineering pieces that we've built to really handle errors at scale. So this is a slide that, this is an image really that may have like a visceral feeling for some of you, like an emotional impact. It's why, the reason like the talk starts with this and the blue screen of death is really that errors are iconic. They have like real emotional impact and emotional weight to them. When you see these things, like you feel them. They have like a meaniness to them, where they really mean something, right? They have emotional resonance in a way that a lot of other pieces of software do not. I want to take a look at just a couple of others as well. This is a 404 page that I'm sure many of you are familiar with and have hit before. This one, for me, has like a very visceral, like hopeless feeling from days when I wrote C++ code. That feeling that the compiler is not going to help you and you are entirely on your own to try and figure out what went wrong. It has like a real impact in that it is something that is supposed to be helpful, but when it looks like this, it is completely unhelpful. It's rather the opposite of helpful. So that's another one. Errors end up in art, right? They're meany. They end up in art. This is like the quintessential like frustrated moment in Office space where like everything breaks down is around the frustration of seeing this completely undecipherable error around your printer, right? Another example is one of my favorite essays about software engineering talks about e-timed out and what it means to see that error when you're a systems developer or a networking developer, and kind of like you don't really know what to do. Some of them are so memey and have like been seen by so many people that we've like written entire like poems or parodies, in this case of Edgar Allan Poe's The Raven, about like the abort, retry, ignore, abort, retry, fail. If you ever had like a floppy disk that you put into a machine, a DOS machine many years ago, and saw this prompt where what is the difference between abort and ignore? It's unclear, right? Or retry. So those kind of like very frustrating moments like unify us and bind us in our usage of software. This is another one that maybe has like some emotional resonance for people. Early Mac users, this is the kernel panic or crash screen, the equivalent of the blue screen of death. This one is really interesting to me because of how it's actually this concept of like the sad computer, this representation has actually like been carried through over the years. This is the more modern version of it, and I hadn't like until I was putting this presentation together like really connected that they were the same concept, right? Of like that the sad tab was really an homage to the sad Mac. And even these days, the blue screen of death that we started with looks a little bit different on modern Windows machines, but the sad face also there really. So cross-platform sad faces at this point. It's pretty good. Okay, so I wanted to start with that just to like kind of like center us on like why errors are important, why they're universal, why they have emotional impact, and really talk about their meaning to us as software developers. And before we go further, I want to talk about what is an error, what is an exception. What I said here is there's nothing exceptional about exceptions, and we'll kind of get into that. The first thing that I did when preparing for this was like looking for a definition of what is an error or an exception, if you were to like formally define it. And Wikipedia has a kind of antiseptic phrasing here that exception handling is the process of responding to the occurrence of exceptions, anomalous or exception conditions requiring special processing during the execution of a program. And that's probably right. It misses one thing, and I disagree with it in a little bit. It rubs me the wrong way in that I don't think that errors and exceptions are exceptional. I think that they're expected. They are normal. There is no program that you have written that has never encountered an error or an exception, right? And even the languages that we use to build them have constructs built into them that are around the premeditation of dealing with errors and exceptions, right? And so they're not really exceptional. They really are a fundamental part of building computer software. And that's really what's kind of so interesting about this is even the name exception implies that they're not. And we get into this situation as developers where we tend to think that errors are exceptional, that they are that they are an afterthought. We tend to think in happy paths, right? Of like, this is what happens whenever everything goes right, and the error or the exception becomes an afterthought. But it really shouldn't be, because they are expected and because they are common. One quick note before we go on here, I'm going to use the term error and exception interchangeably for this presentation. When I say error, I mean exception. When I say exception, I mean error. They're equivalent for the purposes of this presentation. I don't mean bugs, though, not things like errors in the software that you wrote. I'm talking about some kind of error condition that the software has detected, not like a bug in the code. So errors are really just another type of function result. When you ask a piece of software to perform a function, it will return a result, or maybe it will error, but the error is really just a different type of result. Sometimes you get a result which is a number or a string or something like that, but the error is really just a different type of result, but still a completely valid return from that piece of software. When you do encounter an error, what they likely mean, right, is that the other results that you were expecting are invalid or incomplete or unreliable, perhaps. And in cases of software that performs like some side effect, it means that the side effect's behavior is often unknown. Sometimes, the errors will actually document, and you as the developer can document what those side effects will be. If your fire is launch the missiles and it errors, like, did the missiles launch? I don't know. They may have, they may not have, but the error is a good indication that you don't know at that point. So before we go on, I want to look at some of the common ways that we look at error systems in programmers, in software development, across different programming languages, across different programming paradigms, and use that as a way to center and all get on the same page, have some of the same terminology and a shared frame of reference, a shared vocabulary for some of the pieces that we'll talk about later around error design. So this is C. This is where I got started developing. And it's a really good place to start this particular conversation because C doesn't have a built-in error mechanism, more or less. When you want to return an error from a piece of C code, there are many patterns, but the most predominant and common pattern is to return an integer. And essentially, your function returns an integer, 0 means success, any other number means failure. And so when you look at C code, you'll see lots of code on the bottom of the slide that invokes a piece of software and then checks to see if the integer is 0 or not. If it isn't, usually sometimes 1 just means failure and you don't know what the failure is. Other times you can actually look up a particular, each different integer that could be returned has a different meaning of how the function failed. This is a good place to start. It's really primitive, just in terms of the bandwidth that's given to exchange information across that function boundary of how much information can you communicate about how the error has occurred. And in C, because of these limitations, there were all sorts of workarounds that were created to communicate additional error information. And those really got funneled into better language designs in more modern languages that we'll look at next. The most common, I think, at this point, error handling mechanism that you've probably seen is around exceptions. So an exception is something that a piece of software throws and essentially unwinds the call stack. It has its own built-in piece of the language to actually catch that error. In some languages, you can actually document or ask the compiler to know that your particular piece of software is going to throw a certain type of exception. Java works like this. And then basically you call the code and you write. And this, we were talking earlier about how pieces of software are centered around this happy path. And really this control flow mechanism is centered around that happy path idea, right? In your try block, you write all of the things that are going to work, right, in the happy path, and then if anything goes wrong, you skip to an entirely separate portion of the program, and that's where you handle your errors. It has some interesting problems, right, where you don't know like from where in the try block the thing failed. And it's one of the reasons that some of the more modern languages have started to move away from this particular type of pattern. But it is one of the more common ones that you see, and probably one that the majority of you are familiar with here. This is a more common pattern in modern languages. So these are, especially in like functional languages, have started to think about errors in this mechanism. And what they're thinking about here is going back to what I said, that a function's return is really just one of two possibilities. It's either the result or the error. And that codifies it in a way that it doesn't interrupt control flow, that the result of the function is returned, just like any other result from a function. But it could be one of two things. This is usually expressed as like an algebraic sum type, saying that the return type is either this result or it is an error. So these are common languages these are new languages, I suppose, modern relative to something like C or Java that are taking this type of approach, which gives the developer a little bit more control and enforces the pattern that you handle the errors where they occur, that control flow does not jump to another place in the program. It allows you to keep your context. And the interesting piece about this, right, is that there's no new language mechanism. Like there isn't, in this try-catch world, you've like invented a new piece of the language. Even in this mechanism, there's no like special error type. In fact, the only thing that's really a type here is like this tuple type that's being returned from the function. The fact that one of the types is the expected result and the other type is an error type is really up to the developer. You could return two result types or two error types or two result types and two error types. Right? There's nothing inherently special about it. You're using other lower level mechanisms of the language and not inventing something special to handle errors. And that harkens back to what I was talking about earlier, that errors are not special, that they are expected, right? That they are normal. And this sort of pattern is a way to like kind of feel that reify. This is an example from Rust. It's the exact same pattern of using this result pattern, but a lot of the languages, Rust in particular, have started adding lots of mechanisms to add syntactic sugar to make kind of like when you end up handling errors on every single function call, it gets tiresome and boilerplatey. And so there are a lot of folks who have added syntactic sugar. Rust is a good example here, where it adds that syntactic sugar around checking those error mechanisms, and there's even another one that makes it a little more terse as well. Go is another example. This is the same result error pattern, but it does so using multiple returns instead of a sum type. This is more or less the same as the ones that we just looked at, except it's a little less type safe, essentially, because there's not like a true compiler enforced invariant between there must be a result or there must be an error. This is just a survey of some of the common things that we've seen in common languages that are in major use today. It is by no means trying to be exhaustive of how we handle errors or the whole history of how software development and software languages have thought about handling errors. There are many different approaches. These are definitely the most common ones and the ones you're seeing in the most common languages, but there are some more obscure and arcane mechanisms that I'm not covering here. And the last thing that I want to mention here is that even though one of the interesting pieces, we kind of like looked really closely at the difference between like this control flow jumping exception handling and the result-oriented type, is that all of those languages that actually do the result-oriented kind of tuple return value still have an exception mechanism. It turns out that there are pieces of software that always will feel exceptional. Good examples of this are like when a program divides by 0, that is not like a function call that always should return to you like a result or an error. And so for these cases, pretty much all of those languages have ended up in a situation where they've built both mechanisms, but even separating out those mechanisms has been tremendously valuable for them to treat the majority of errors in this kind of like common error pattern and reserving exceptions for truly exceptional circumstances where you normally wouldn't want to or couldn't check for an error at every operation. Yeah, I think that covers it. The last thing that was just interesting as I was like kind of compiling all these pieces was around the exception control flow mechanism, is that there are many different variants of the control flow pieces. They all have different names. None of this has been standardized. Everyone has used like different keywords. And even the way that the control flows between those exception pieces changes from language to language. But at the end of the day, if you like really look at them, they all kind of feel the same. Of course, handling errors is not specific to within a piece of software, right? Like within a particular program, that is one way to you do have to handle errors within your own pieces of software. But your software talks to other pieces of software. It talks to the kernel. It talks to other programs on the same machine via IPC. It talks to remote programs via RPCs or via the network. And when it does so, it's invoking some kind of remote operation and needs to receive an error signal back. But because you're talking between two vastly different systems, two very different programs, you end up back towards this like kind of the C world where you're working with very crude mechanisms again. And you're really getting things just like an integer and arbitrary bytes, right? When a Unix program is running, like it has an exit code, which is again an integer, which makes sense from the fact that Unix and C are very tied together in their provenance. And same with like RPCs. When you're like making an HTTP request, there is an integer, which is the status code of the error, and then essentially the body of the response, which you can fill with anything. And there's no real specification about how you communicate any additional error details. That's really up to whichever applications are sitting on either side to negotiate. And so you kind of end up back in this situation where you're dealing with very crude things. And the more designed and the more closed your ecosystem gets, the more you can add more structure on top of the errors that you're returning and exchanging. Before we move on, there's one other interesting piece of error handling that I just wanted to mention briefly. We're not going to really talk too much about it, but there is this one other like very interesting class of error mechanism that exists in pretty much all the programs that we use, which is this ability to like interrupt the program and say like an error occurred, but not explain to you where it occurred from, or to like you require additional mechanisms to go determine more information about this error. Good examples of this in two very different places are like in Unix programs, even Windows programs. They have the ability to be signaled, which basically interrupts the program at any particular time, no matter what it's doing, and calls some kind of function that tells you like, hey, some kind of exceptional interrupt thing happened, like you need to handle it. But similarly, that same kind of like callback of like an error occurred somewhere exists like even in the browser and in the JavaScript ecosystems. These types of control flow mechanisms are very difficult to work with, right? Because the provenance of the error like doesn't exist in the place where you captured it, right? It's a callback where you have to like go out and like try to determine where the error occurred. It's a pattern that is usually reserved for cases where some kind of like system generates an error internally that you really didn't invoke or call, but needs to notify you of it in some way. So that's the other kind of like common error handling pattern, but is usually reserved again for exceptional circumstances because of the difficulty of actually dealing with those errors. Okay. From here, we have like a good idea and like a common shared frame of reference on like what errors look like in software and how we handle them. What are the mechanisms we've used to think about them? I want to talk a little bit about like what happens now that you've caught an error, and then we'll dive into designing better errors when you're working with them. So there are really only two possible choices when you encounter an error. One is, despite kind of that abort, retry, ignore, maybe there are three, but really there are two very important ones. You can either choose to handle the error, which means like you catch the error in some way and then decide to do something about it, or at that point, your piece of software that has encountered an error can say, I cannot continue with this error. Like, I'm going to hand this error or a different error back up the stack to someone else, and like I have now errored as well. And this is like a very simplistic. There just aren't many choices here. Like you really only get two. It doesn't make for great talk content, but the simplicity of it is actually really comforting that you really only have these two options. And I wanted to call this out like very explicitly because it kind of thinks about it kind of helps us think about the developer interfaces for dealing with errors that we'll chat about a little bit later. So let's talk about each of those two cases. One of them is handling errors. And really, your choices are limited here as well. When you capture an error in your program, you can choose to try again. You could choose to try something else. Or if you really don't know, you can choose to ask the user what they would like to do. Would they like to try it again? Would they like to try something else? And those are kind of your only options in terms of actually like handling the error. When you're returning an error, essentially like the ways that software handles these errors and returns them back is to say, well, I can either return the exact same error back up to my caller, I could return a different error, right? Or I could return a wrapped error and kind of like embed the context of the error that I observed into some sort of larger error that explains more about what I was trying to do versus the low-level operation that actually failed. At the end of the day, those are really the only choices that we have, and that's going to feed into how we think about designing errors, both for end users, and it's going to factor into how we think about designing errors for developers. So with that, let's kind of like jump into the meat here of thinking about how to design errors for end users. This is one of the things that's really interesting and really fascinating to me is that errors, they are one of the most under-designed pieces of a product. When we like design our mocks at ngrok, like there are like lots of screens and wireframes, and they show dialog boxes and user flows, but they never show any errors, right? And in the cases that they do, like the error text isn't like really thought about deeply. And so like we end up, you know, writing those errors like after the fact. And what that ends up meaning is that the error interface is one of the pieces of the product that is often controlled by developers, right? Like a product person did not design all of the errors that you see in all the software that you used. A lot of it was designed by developers, and it's one of the reasons that I love to encourage developers to think about errors, because it is a piece of product design that you are often very responsible for. I've got a number of examples that prove that errors were designed by developers or folks who weren't actively thinking about product at the time that they wrote them. There are a million examples of like tremendously unhelpful error messages that you can find on the internet. This is one that is definitely amusing, that it asks you to start the service, but it can't start the service that it's asking you to start. Please click OK to continue when your mouse doesn't work. We can't save the file because the saving was interrupted. This is another type of like very interesting failure where essentially like the actual like raw database constraints are like being surfaced to someone who is trying to buy a movie ticket and definitely does not know what a database is or how to use one or has access to it. And should never see anything like this. And sometimes you just get things that are just completely unhelpful, right? Where there was no text even designed. And I really want to harp on this because errors are how users learn to use your product, right? These are the things that are surfaced to end users in like their most frustrated moments using the product. And they're really a critical tool for users to understand how to use the product and what to do next, right? They are what you see when you've encountered a problem that you can't get past, right? Or you did something wrong. You were trying to accomplish a goal, and you failed to accomplish that goal, and you want to, right? And they are supposed to be the piece that guides you to that next step. So they're a critical part of using the product and making sure that your users do the right thing, and yet they don't get very much attention, and they are often not very well designed. And so I wanted to spend a little time thinking about how we can make them better. So the way to talk about this is just like starting out thinking about like what makes a good user-facing error. What are all of the different criteria? Like what are the patterns that we should be using when we're trying to make a good user-facing error? And what are the instructions that we can give to a user? So we're going to start with 3 of the kind of like high-level pieces here of how to think about writing good error messages, and then we'll kind of get into some of the details afterwards. At a high level, like the 3 things that you want to communicate to a user when you are designing an error message are what failed, why did it fail, and suggesting a fix. If you get those 3 things, you are golden. There are a bunch of additional things that you can do to make it better, but at the end of the day, those are the 3 most important pieces of an error that you can communicate back. So what failed is the first piece of like, what was the operation? Like what was trying to be accomplished that failed? This is an example of an error message where I have no idea what they were trying to do. I could make guesses based on context from the error, but I have no idea what the software was trying to do. And so explaining to the user what the software is trying to accomplish is pretty critical for them to understand like what they should do to fix it and the context in which the error occurred. There are cases where you want to omit this, right, when the context of what happened is obvious. So if like the user just clicks the save button and they get an error back, it's very obvious that the program was trying to save something, right? But if the save operation is very complicated, it's doing a lot of things, like maybe it's an installer and you clicked install, saying install failed is not particularly helpful, or saying nothing is not particularly helpful. Instead, you want to explain what inside the installer failed, like the particular step is usually a more helpful way to communicate that context. The next one is why did it fail? Here's another example of an error that does not explain whatsoever why the operation failed, simply that it did, which is a very frustrating experience. You want to understand why, because that is one of the keys to how you can fix it. There's one caveat to explaining why, which if you think back to that example of buying movie tickets from AMC, is that you don't want to explain details that the user has no control over or can't understand. If the why is the database constraint failed to someone who is buying movie tickets, that is the same as saying like, there is a bug in the software, like your developers made a mistake, right? That's a more meaningful, or like the website crashed, is a more meaningful explanation of like what or why it failed versus stating something about the underlying implementation. So this is one of those places where you have to gauge your audience and who's going to see the error message in order to be able to communicate it. But in general, explaining why something happened is pretty important. If the reason is internal, like internal server error, that's become common enough that folks kind of understand, but you will see like better error messages from operating systems these days that say like the program crashed, which is a much better explanation than internal server error to explain to an end user who is not a developer what's going on. And the last piece is to suggest a fix. This is another example of an error message that does not tell you at all how to fix the problem. It simply says, the application failed to shut down. It does tell you why, which is nice, but it doesn't actually give you any helpful tips about how to go about fixing it. Sometimes there are cases where there is literally no remediation to be done except for like try again or restart the machine. Those are acceptable things to say in these cases, but usually you want to be a little bit more targeted and explain very clearly, like, here are the set of steps that you could take to try and resolve this issue. This is an error message that ngrok returns around trying to accomplish an operation. It says only paid plans can do this. you failed to use this subdomain, sign up here. If you've already signed up, make sure your auth token is installed. If you break down the pieces of that error message, you'll see the first part is the why, which is why the operation failed. Second part is the what, which is the thing that you were trying to do. And the third part is the fix, right? Of here are a bunch of suggestions about how you can accomplish the goal and get over or through this error message. This is, I don't know, these are the three component parts of it and a good example of how to do it. The last thing I guess I'll say about this is hard. It's hard to do for every single error message in your product. I would not pretend to say that ngrok does all of these things or does them all well on every single error message. It is a constant. There are so many errors that can occur across the product that is really a huge effort to make sure that you really follow these principles for every single one. But these are the guiding design principles that we do try to stick to for each of the errors that we create. Okay, so let's say you have the what, you have the why, and you have the suggested fixes. There are a number of other ways that you can improve the design of errors that you communicate to your users, and I'm quickly going to go over some of them. Many of them are optional and kind of context dependent. This is an example of one, which is explaining consequences. Sometimes we talked about how software has external side effects, and if someone is engaging in one of those operations, you usually want to be really clear to say your card was not charged or your card was charged, because if you leave that ambiguous, you create a lot of confusion for the end user. Another one is to point to the input. So if a piece of input causes an error or failed in some way, you want to point at directly the thing that is causing the problem. You've probably used forms where you've seen an error at the bottom of it that was there are errors in your form, or there were 10 errors, please go fix them. A much better pattern, right, is to highlight exactly, or sometimes they'll just put the error message at the bottom, the zip code was invalid, instead of highlighting the zip code field, right? This is true across both, end user applications, developer facing applications. The second screenshot in here is from the Rust compiler, where you're trying to compile something and it says this particular line, and within this particular line, this particular character is the thing that I was trying to handle, and it's not appropriate. Surfacing that kind of context and placing the input and the failure within the input directly where the user can find and fix it is tremendously valuable and will improve the experience of any product that you're using. The thing that I like about this, these two screenshots next to each other, is that this is a concept that transcends to very different audiences and very different mediums, like the console and the web, developers and end users. But really the overarching principle of making sure that you're pointing directly at the problem area transcends both of those cases. Messages, be succinct. It is tempting to be verbose in the error messages that you write and try to explain everything about them. That is something that you have to balance, the clarity that you get with additional words versus the fact that no one wants to read. This is kind of the golden rule of product design, is that nobody reads. And so the fewer words you use, the more likely you are that people are going to read them and get your point across. So try to be succinct. It is, kind of like the famous quotes about if I had more time that I would have written less. This applies directly to error messages as well. The more time you have, the shorter you should be able to make them by designing them better and being more clear about exactly what's failing. Another one is not to blame the user. This is a common pattern. It will say you entered something wrong. You put in invalid input, which is not really helpful and creates an antagonistic relationship with your end user when you really don't want one and don't need one. And instead, it's much better to take the third person approach and say this input, use I words, not you words, kind of behavior here. Fail fast. So this is, client-side validation is a really common pattern here of for like browsers of trying to surface errors to the users, to an end user, as quickly as possible. If you're thinking about as a developer, like if you're using an IDE, right? This is your IDE like highlighting, bad code as soon as you're typing it, before you have to like wait for a compile step. The sooner you get feedback to someone, the faster that they can repair it. The other thing about this is really you want to like try and do as many validation checks as you can up front, especially for long-running operations. This is a dialogue that I used to see many years ago when I had like dial-up internet, where things took forever to download, and the feeling of dread that an operation would fail at like 80 or 90% and you would have to start over was awful. And so if that's like because the network flakes out, there's not a whole lot that you can do. But if it's something like, oh, you ran out of disk space and this was a thing that the program could have checked up front for me before it started downloading, that's a very nice thing to do and much encouraged. One more is about multiple errors. This is another one of those that like, again, like transcends medium, right? If you're thinking about using a compiler, right, you will notice that a compiler spits out like 10 different errors at a time or more than that, right? Of like, here are all of the failures that I found in your source code. Similarly, if you're using a web form, you might see here are the 5 different errors, and I've highlighted 5 different fields for you that you failed to input valid data into. The more errors that you can surface simultaneously, the faster that users can fix them. It is a very frustrating experience to, submit a form, and it tells you one field has failed, and then you fix that one, and then another one is wrong, and then another one is wrong, and another one is wrong. Very frustrating. So the more that you can get simultaneously without overwhelming an end user, super valuable for the user experience. And then there are a couple of pieces that are, very specific and targeted to developer tools. Example of this would be include a unique error code. For non-developers, this is not really the kind of thing that you want to put, like when you buy an AMC movie ticket, an error code there is not particularly helpful, but a specific error code from a compiler or a specific error code from a library that you're trying to use, really valuable from a database, right? Because then you can go to the documentation, plug in that error code, and figure out what's wrong. Same goes for including a URL, which is tied directly to that error code. And then for online services, any kind of like API that you're building, highly recommended to include a trace ID if you have any kind of reporting behind the scenes that has like a unique identifier for every operation in the system, and including that to your users so that when they encounter an error, they can tell you the exact one that failed, and that allows your debugging and customer success and engineers to go track down exactly the piece that failed, because sometimes those failures are intermittent, and so having like the exact traces is super valuable there. Okay, that covers the pieces for design for end users. I'm going to spend a little bit more time on designing for APIs for developers. And for this, we're going to ask ourselves the same question, like what makes a good error for a developer? We're not going to talk about the users. I'm not talking about like messages in this case like we were in the previous section. What I'm talking about is like the design of the API. Errors are, if you're using a library, another piece, or even like a software service, they are part of the API surface. And they're part of the API surface that's very often ignored. And so this is one of the things that frustrates me very often, and I'm going to harp on quite a bit here. We'll go into just 2 of them because there aren't too many things that I really want to cover here. There are 2 major pieces, 2 major flaws that I see in a tremendous amount of software that surfaces errors. One is that it's very hard to distinguish errors, and the second is that you can't access underlying causes. And we'll look at both of those points independently here. So the first is distinguishing errors. When you perform an operation, there are usually different ways in which it can fail. For languages that have exception handling mechanisms, they give you the ability to essentially handle each one of those independently. Like, here's a file not found exception, here's a runtime exception, here's an out of memory exception. There are different ways to like pull out a specific type of error. The only problem with this is that the majority of software and libraries and developers who have written them tend to lump a whole bunch of different errors into the same type, because no one wants to create a different type for every single different unique error condition in their piece of software. While it is very frustrating to do that, as an end user who is trying to write software that consumes a library or a service, it is incredibly frustrating to not be able to distinguish those errors from each other in a programmatic way. So the two guidelines I have for you there are really to use either a unique error type for every distinct error that your library or service produces, or to use, if you want, you can use a single type, but have a distinguishing code, like a unique symbol, essentially, that defines every single error that your program can return. It is work. There's no like shortcut or easy way around it. It is simply a matter of diligence, but it will make your APIs tremendously better for other developers to consume. And when you do that, that avoids this situation where you end up in situations where this doesn't happen, and this is code that is actually in the ngrok code base where we were trying to detect connection closed events. But the networking library in Go, which is what ngrok is written in, does not surface a different error type for a closed network connection. It does have like a network error type, but within that network error type, you can't ask like, was it because the peer hung up, or was it because the connection closed, or was it because the socket like ran out of file descriptors, or any of those things. And so that means like we have to do this kind of string checking, which is very fragile because that string is not part of the defined API. We could rev the language version, and they simply could decide like that was not a very clear use of language. Maybe they will have watched this talk and thought about the guidelines of how to write an error message and have changed their errors, and then our code will break. That's an incredibly frustrating place to be in, and it makes our code very fragile in order to do this. So that's really why you want distinct error types for every error that your library or service can produce. The last piece is about error wrapping. So error wrapping is really about balancing two concerns when you're handling errors. One is that developers need the underlying or original error or context when they're trying to handle an error. Like, what was the thing that failed at the very bottom, right? Of like, and I'll give you an example of this. And so this is like the cause. Like, what was the original error, the thing that first broke? But they also need the context where the error occurred. So like, let's take a look at an example here. This is a function that inits a game. We're building a game, and the first thing that we do is we load all the 3D models, and then we load the save state. Presumably, we do a whole bunch of other things to initialize the game as well, but just those two will work for this example. If I called just load save state, and I got an error that said too many open files, I have a pretty good idea that like I tried to open the save state file, and it failed. And that's like a pretty good indication to me of like where the problem is, which file it was trying to open, and how to fix it as a developer. But if my init game function returns too many open files, I have no idea where that is, right? Maybe it was loading the 3D models, maybe it was loading the save state, maybe it was loading any of the other files that a game needs to load to start up. And the fact that I don't know where it came from is very frustrating. And so this is where this concept of error wrapping occurs, where like, when you get, if your game like just exited and said too many open files, not helpful at all, right? But if the game exits and says too many open files while loading 3D models, say, I know where this problem is, I know how to go fix it. And so this is this concept of error wrapping and like putting errors inside of other ones to basically like capture the trace or stack of all the different, of where the error came from, but still explaining how you got there. In some languages, this ends up getting fixed in languages where you like have exception handling and this bubbles an error all the way up the stack, this is somewhat a solved problem in that the call stack that you get shows you exactly where the error came from, and it also traces how it got there, right? And so those things are merged into one. But as soon as any code like that tries to handle an error, right? And so it has like a try catch, and it like tries to do something, but maybe it didn't work, and so it needs to say like, no, I'm still failing, and returns that error back up the stack. You're in this situation where you no longer understand where the error came from. So Java has a mechanism where they actually allow you to more or less wrap exceptions inside of exceptions and have like pointers all the way down to get to the original cause. Go has something similar to this. This is something where I haven't seen a tremendous amount of languages like build this concept directly into their error primitives and error libraries, and I would like to see more folks doing that. It's especially valuable and meaningful inside of a language. Across like a service boundary, if you're like producing a public-facing API, usually less relevant here. Okay. Time to wrap it all up. The last thing that I want to cover here is about some of the lessons that we learned, basically taking all of these different concepts and designs at ngrok and building them into a practical system. So I want to show you a little bit about how we manage errors at ngrok, and then tell you a little bit about the benefits that we get out of it. So at ngrok, every user-facing error in the entire system are all defined in a configuration file, essentially. It's spread over multiple configuration files, really, but we have basically a list of thousands and thousands of errors that the program could return to our end user, and they are all documented up front with essentially a unique code for them, as well as a template for how they're rendered to the user. And then what we do is we have a piece of code that basically does code generation, where it loads that configuration file and it spits out code in all of the different languages across ngrok that we need to send errors from or return errors to the user. So inside that configuration file, this is a simplified version of a definition of an error. An error has a name, it has a template, it has a field which indicates whether it is documented publicly or not. It has a field which indicates whether it's internal or not. All of our user-facing errors are done in this way, but even some of our internal errors are documented or built using the system. And then it has a unique code as well. So here's an example from one of our real configuration files of one of these errors, right? So it has a code of 16. It has a name that is bind ACL forbids name, and then it has a template with some variables that can be patterned into the error message. This is essentially in like a JSON-like configuration file. So then our error handling or our error generation code reads this file along with all the other ones, and it spits out a whole bunch of Go files, a bunch of TypeScript files, Python as well, I think. And here's an example of a call site where we're actually using the generated function. So the interesting piece about this, right, is that when we're using this error, we actually have like a real typed definition that is generated for us. So it means we're type safe in the template values that we're putting into it. And we will get a compile time error if the software like doesn't use a correctly named code up front. This actually is one of the ways that we ensure that every single one of our errors is documented, because you can't return an error to a user without it being defined in that file, and the documentation for every single one of our errors is generated from that file. So it creates this really useful parity where we know that every single error in the system is defined and documented because it's generated in that way. Also has a tremendous benefit for customer success and support as well. This is an example of some of the messages that we get from our customers, where they say, like, I had error ngrok 804. And so when we get these kind of emails, we know exactly what problem the customer hit inside of the code, inside of our service, right? Normally, before we had to introduce the system, we would get customers who would write in and say, ngrok doesn't work, or it failed, or I failed to connect, or whatever it happens to be. But when you surface these really public identifiers, especially to developers, they are really easy ways for you and the customer to very quickly communicate what's wrong, even across human natural language barriers, right? If someone is writing in from a country where they do not speak your language, this is still a concrete identifier that they can send to you, where you have an understanding of exactly what happened. One of the other reasons that we designed the error code system in this way is that, as you developers know, when you encounter an error, what is the first thing that you do is you copy the error and you put it into Google and you say, who else encountered this error and how did they fix it? Because I want to do exactly what they did. And we know that, and so we designed the product specifically in that way, where we made sure, essentially, that we put a unique prefix on all of our error codes so that they are globally unique in the world, essentially. And so what it means is that when you type error ngrok into Google, or you put in a specific error code that you get back from our system, that you will land either on our pages or community pages where people have run into exactly the same error. If we change the wording of the error over time, we decide we didn't address the how the what, the why, and how to fix it, and we rewrite the error message, it will still land people on the same place. So we have the ability to change that, but still allow our developers to always find the correct content. The other huge benefit it has for us is observability. Every one of our egress points, our API surfaces where a user can interact with the system, understands all of the errors that can be, or understands the way in which an error is rendered to them, and understands that every user-facing error has a code, which means that in our observability dashboards, we can see every single code that is being returned to users, both in aggregate and within a specific user's account. This makes it tremendously easy and super valuable to zero in on exactly what are the most common errors that are being rendered across the platform, as well as if a particular account is having a problem, being able to zero in on which errors that particular account is hitting. So just recapping there quickly. One of the main benefits we got out of this is type safety and kind of language independence. I didn't really show the generation code. It's kind of a little too far afield and in depth, but really what's going on there is we are spitting out essentially type safe definitions for these in every language that we use, including the browser, right? So the JavaScript or TypeScript code that we ship to the browser uses the same set of error codes and the same error system and error namespacing system as our backend server code does, even though they're the function call sites are being generated differently. Same system, right? Our goal, we're not quite there yet, but we're most of the way, is that really every single error returned by ngrok has this unique code. There are some pieces in our kind of downloadable agent that still need this treatment, but that's the end goal of what we're driving towards. We looked at how this is super beneficial for customer success and triage, where you can very quickly identify what errors people are running into. We looked at how it has benefits for product observability, both for customer success to understand what folks are running into, as well as for product to prioritize what errors to improve messaging for. The documentation pages, by the way, all of those things that people come to when they search, when you collect analytics and observability on those pieces, you can also plug that into your mechanism of what do we need to document better, or what do we need to fix in the product so that people don't encounter this error more than the other ones that they're hitting. There's a meaningful difference between an error that you return very often versus ones that people search for. Ones that people search for are ones where the product has not helped them to solve that problem and they need additional help. We've talked about how this allows us to generate exhaustive documentation and make sure that we don't actually return any errors that are undocumented. And then we've also, the one thing that I didn't mention, I guess the last two pieces, one is that that system actually allows for really easy internationalization. You can substitute in templates for different languages, different natural languages, to render to the users very cleanly because it's fully separated out from the software. And the last piece to mention there is that Going back to the section where we talked about how do you make error systems really good for developers, is that when you use ngrok's APIs, if you access them and they return an HTTP error to you, in that JSON body, this unique error code for us is returned as part of one of the fields, right, the documented fields in our API responses, which means that no matter what error you encounter when using ngrok systems, you can always switch on that particular error code type, which allows you to create essentially custom logic for any particular error in the system that you could run into. All right, that's really all I've got here. I want to thank you again all for your time. Thank you so much. It's been a pleasure being here. Before I step off here, I don't know how much time we have, but regardless, come find me afterwards in the conference. I love talking about all of these things, developer APIs, developer design, and building really fantastic user interfaces. I would love to chat more with you. Just come find me anywhere, and would love to do that. So thank you all.
Thank you, sir. Appreciate it. I would have said give him another round of applause, but you just did. It's funny, when we started that.us, we started with the mission to lead everything and make it all open source. And with that came lots of new challenges, and all ones that I really like. But the thing that like Brett and I constantly, every day, when we start thinking about our errors and the things that happen, like Alan just a bit ago said, it's kind of two things. Either we did something wrong or the user didn't know how to do something, right? At least I'm like, hey, at least they're using the system, right? Or we just kind of failed somewhere. And the best thing about small companies that I just love is constraints. There's not a lot of time. And when you start to invest in certain places, you realize it gets a little bit better. And for us, one of the places that we desperately have to invest in is things like errors. How do we react to how people use the system? It's also great feedback for us, because I can say, hey, I see that you're over here, and it's erroring, but there's nothing happening over here. Now I know over here has errors. You're just not using it. So it's just, it's one of the things that I know across a lot of things that we end up forgetting, right? Instrumentation, errors. It's like, ship it, get it done. So it's super cool. As Alan said, he's going to be around afterwards for some questions. I was just talking to some of the folks there at ngrok, and I was like, yeah, go to open spaces. Like, let's get him over in open spaces right after. Ask those questions. Have that contextual conversation about the stuff that's there. And I would encourage you, ask the hard questions. They have a platform that is running stuff globally at a scale that some of us could never even dream of. And while that may not necessarily be applicable to your particular thing, there may be some secret sauces in that. So for sure, take the opportunity to talk with him and the folks over there. Certainly go check out ngrok. It's one of my tools. I wouldn't stand up here and tell you to use this thing. It's the thing I tell everybody to install no matter what. So let's give Alan another round of applause. It's a super important thing to me to have folks like that here is simply because of you. I want you to take that. I want you to think about that. You didn't do some special sauce to have to convince him. He's here because of you. Now, like errors, I suck at communication. Some of you have said, hey, I think I missed the thing. I did this. I'm trying to get better. Newsletters, emails, they're hard. So I'm putting together 3 Telegram channels that are only going to be around announcements. One for Wisconsin, one for Texas, one for just general that news. So t.me, that._wi, Texas, or news, you can see the links there. If that's your we're going to try it out. I'm going to try to stay committed to that. That doesn't mean I'm taking away other things, but I always try to be respectful of your @ channel and making sure that I'm not kind of sliding in too often, but I do want to make sure you don't miss anything either. So I'm putting up another kind of mechanism to do that. Part of me, this has been rolling around in my mind, like this week it had been really great to be able to say, hey, I got to move this room because so-and-so's late and we've had to reschedule things. They're just these exceptional cases, to use the theme of today, where it'd be nice to know that it hit your pocket. So something new we're going to try. Join it. I want your feedback. I'll wait for Lydia to stop taking a picture. No, just take the picture. No, I know you. I'll give you the thing. Few housekeeping things. Open spaces, right? Go get involved. Step out. I know if you've never done it and you look from the outside, you may be like, that looks like a hard step to take. I'm telling you, take the step. Lean in. Family track, not just for families, for everybody. Make sure you stop by the STEM room, check out that wall, or the cube, if you will. Again, the TVs are around, they're meant to be used. Jack in, talk about it, show your stuff. Be proud of what you do. They're there. Ask for help. After lunch, we're going to be up here doing some interviews, looking for people who want to speak a minute or two. I could just capture a little testimonial, get your thoughts. I'm going to try to capture some other stuff throughout the week as well. But anybody who wants to say a few words, come on up here after lunch, and we're going to do a little recording. Check out the trading post. I know you all drink coffee. Is there anybody here that doesn't drink coffee? Oh, wait a minute. None of you drink coffee? Or did I just, oh, man, I got good coffee. Man, there's going to be an intervention later. Pig roast tonight in here. Water park party, got to have a badge to get in. They won't let people through the doors that don't have a badge. And lastly, I want to say thank you again to the sponsors. They're such an essential part of being able to do this, to support everybody that's here. I was talking with some old friends this morning, and they're like, wow, I didn't really expect to get that many people. And I'm like, welcome to the family. Everybody has a little bit something to add here. So thank you. Let's give them a huge round of applause. I can't do this without them. One of our longtime sponsors is CUNY Mutual Group. They've been a fantastic partner through the good times, the bad times. We actually just finished a case study with them. Super cool stuff that they have been able to do. There's a whole bunch of CUNY folks here, so shout out to them. I hope they're having a good time. They're one of our pioneer sponsors. They have been for a long time, and as part of being a pioneer sponsor, you get kind of a special session at lunch where we're not kind of competing with anything. Super cool session that's going to be there. It's in 50, which should be that room over there, Africa 50 at 12:15. They've got some giveaways if you're looking for some free stuff. Stop by, say hi, enjoy the rest of the day, and I'll see you in the hallways. Thank you.